Hello everyone. Uh, in this section, we will be discussing all about motion in one dimension. Okay, so as a first step in studying classical mechanics, we describe the motion of an object while ignoring the interaction with external agents that might be affecting or modifying that motion. So this portion of classical mechanics is called kinematics. So what is kinematic means? That is concerned with geometrically uh, possible motion of a body or system of bodies that without consideration of the forces involved. Okay, so in this particular sections, so in describing the motion, we need to describe in terms of representing the graph like that, uh, in terms of mathematical equations that we derive later on. So in this chapter, we concentrate on the simplest kind of motions, body moving along a straight line. To describe this motion, so we introduce the physical quantities, just like, for example, velocity and acceleration. So first, let us discuss what is all about position, velocity, and speed. So we know that particles' position at x directions is the location of the particles with respect to a chosen reference point that we can consider to be origin of a coordinate system. So we know that position is the location of the object, no, whether it is a person, a ball, or even a particles, no, at a given moment in time. Okay, so considering this a car moving back and forth along with the x-axis. So when we begin collecting position data, so just like for example here, considering this car. Okay, so now we begin collecting position data. So the car is 30 meter na daw to the right of the reference position at x, that would be equal to 0. So atong reference is, ang x na to is 0, no? So we will use the particle model by identifying some point of the car, perhaps the front door handle, as a particle representing the entire car. Okay, so now para ma-describe na tong motions sa usa ka car, so we will need to represent as a diagram, no, which is the x. So x, or distance time diagram, no, para makita nato kung unsa ang uh, ihang behavior, no, sa iyang velocity or motion sa usa ka object. So just like for example here, no, so if we can collect data from time to time, so data sa distance niya from time to time, so we can graph here, no, sa to ang kuan, uh, uh, behavior sa to ang car motion. Okay, so now okay, so let us move to what is the difference between displacement and distance. Okay, so the displacement or the delta x perhaps of a particle is defined as it change in position in some time interval. So the delta x would be equal to our final position minus the initial positions. So for the distance, it is the length of a path followed by a particle. Okay, so what is the difference between the distance and displacement? So distance and displacement are the two quantities that may seem to mean the same thing, yet have this distinctly different definition and meanings. No? The distance is a scalar quantity that refers to how much ground on an object has covered during its motion. While for the displacement, it is a vector quantity that refers to how far out of place an object is. So it is object overall change in positions. Okay, it's just like for example, no, uh, if we walk no some particular place. Okay, now maka-create man kita by uh, by the kuan create og measurement sa ato ang distance with the reference unsa tong reference sa ato ang kuan uh, gilakawan. So distance is ma-measure na to through unsa ra gina-cover ninyo no, na-cover ninyo it's either nga ni back and forth mo. Okay, so you walk 5 meters. Okay, then ni back mo into 2 meters. So it means ang inyong distance na is 5 plus 2. So that is the total gid nga inyong na lakaw, inyong na cover during its motion. And for the displacement is iyahang final nga na displace. So mao na yung kuan kanang pag-measure. Just like for example, i-walk mo into 5 meters, yeah, balik mo sa direction into 2 meters. So ang inyong kuan na measurement for the displacement is equal to 3 meters na lang. So kana. So for the average velocity and average speed. So the average velocity or Vx, average of a particle is defined as the particle's displacement change of x defined by the time interval change of t during which that displacement occurs. Okay, so Vx average is equal to delta x over delta t. For the average speed of a particle, a scalar quantity is defined as the total distance d traveled divided by the total time interval required to travel distance. For the mathematical formulation of average speed is equal to d over d delta t. So when it comes to average velocity, it indicates direction, no? And it can be represented as a negative number when the displacement is in the negative direction. So iyang result ana is in terms of negative number. So average speed does not indicate direction and can only be positive or zero. So sa average velocity, so ato i calculate ana sa iyang by measurement of uh, x direction, x. So pag measure na is iyang displacement, no, unlike for the average speed is iyang total distance gyud nga na cover. So mo natin i-put here sa to ang distance with respect to time. So let us move to instantaneous velocity and speed. So instantaneous velocity of an object in motion at a specific point in time, this is determined similarly to average velocity, but we narrow the period of time so that it approaches to zero. So sa may kanang main objective gud aning nganong gi-approaches niya into zero. Okay, so sometimes the average velocity is all you need to know about. Kung average velocity, no, is all you need to know about a particle's motion. But average velocity of a particle was moving at any given time during the interval. Yes. So to do this, uh, at any given time during the interval, no, but di siya ka-compute kung unsa ang motion with a specific instant of time. Like ang freeze time niya ba at that particular time, unsa gi velocity ang na came up ana during that motion, no? So to do this, we need to know the instantaneous velocity or the velocity at a specific instant of time or specific point along the path. Okay? So, saan na to pagkuha? So, we need to do some limit nga function. So, limit, that is a velocity of x, instantaneous velocity, Vx is the limit change of t as approaches to 0, change of x, over the change of time. So, we know that di man ang entire gud nga time nga atong gi-describe sa pagkuha sa velocity, no. So mao nang nagamit tag limit, then approaches nato into 0. We know that as we move closer at this kaning A to B, no. Kaning B is as we move to closer to the point of towards to A. So we know that mo approach iyang delta t ana is mo, this one is distance, position, and this one is here is the time. So mo approach yun na siya into 0. So that's why we need to use the limit of a function. And this one, in calculus notation, this limit is called the derivative of x with respect to t, written in terms of dx over dt. So by the definition of limit, no, makuha nato ang instantaneous by the application of the motion, no. So makuha nato ang instantaneous velocity. So we have Vx is equals to limit change of t as approaches to 0, change of x over change of t is equals to dx over dt. So just like for example, no, para mas ma-understand pag yun yung pag-ayo. You ride some motorcycle at unsang oras at 1 p.m. So kana at 1 p.m. So as you as a time pass by, so naka-came up kasi yung mga or curious ka ba unsa na kayong motion sa kaning motorcycle at just like for example at 1:05 p.m. no. So unsa kung ato na i-freeze ang time, unsa na kay motion nga na unsa kay motion ang came up or unsa na velocity ang came up ana. So mo na ang instantaneous velocity. Ang velocity nga with the gikuha nato ang velocity with the specific instant of time. So for the instantaneous speed of a particle, it is defined as the magnitude of its instantaneous velocity. As with average speed, instantaneous speed has no direction associated with it. So average speed and instantaneous speed is what we also called as scalar quantity, no. Because wala man sila nag-need of direction, no. It only the magnitude lang iyang required. So let's have a sample problem 1. So calculate the instantaneous velocity of a particle traveling along a straight line for time t is equal to 3 seconds with the function x is equals to 5t squared plus 2t plus 3. So first, we are going to do is to i-derivative ni nato no ang kaning function. So unsaon man using our power rule. So if you remember pa sa inyong differential calculus, so this one, this 5t squared no, ang kaning giray sa ani is mo go down to this coefficient no, then minus siya, ma-decreasean siya og 1, di ba? This also t is in terms na lang og constant or 1, di ba? And this one, this constant 3 would be equal to 0. So as defined for the limit of a function no, that is equal to also the dx or the derivative of the position with respect to time, so we can get the value of instantaneous velocity for the time that is equal to 3 seconds. So we have 10t, so di twice niya, 2 times 5, 10t plus 2 is equal to 32 meter per second. So we have sample problem number 2. So the motion of the car is provided by the function x equal to 4t squared plus 10t plus 6. So compute its instantaneous velocity at time t is equals to 5 seconds. So to do this, so we need to get the result of the derivative of this function. X is equals to 4t squared plus 10t plus 6. So by the definition of limit of a function, so we have here, so change of x over change of t is equals to dx over dt. So kung ato ni mapanaog ang kaning 2, so may mo siya 2 times 4, then decrease by 1, so may mo siya t. We have 8t, then kani may mo 10 na lang. So 8t plus 10, then substitute the time nga gi-required, which is 5 seconds. So 8 times 5 plus 10, that would be equal to 50 meter per second. This one is sample problem 3, no, actually. Sayap lang. So the curve below shows position S measured in feet as a function of time t measured in seconds. The dotted line is tangent to the curve. So A, find the average velocity over the interval time from t is equals to 0 to t is equals to 3 include units. So find the B, find the instantaneous velocity at t is equals to 2 include units. So find the equation of the tangent line. Okay, so for the A, we have here the formula for average velocity, which is delta x over delta t, no? So we need to find out kung unsay iyahang displacement, no, with respect to interval from t equals to 0 to t is equals to 3. Since at the time of equal to 0, sa iyang position, iyang initial position is sakto ba sa atong figure here? No, at initial position t is equals to 0, na iyang position is nasa 5 meters, no? When the time is equals to 3, so iyang position here, this figure shown, is nasa point at 0 meters, no? This one is 0 man. 1 meter, 2 meter, 3 meter, 4 meter, 5 meters. So initial time 0 is nasa sa 5 meters. At initial at a final time equals to 3 seconds. So iyang final position is nasa 0 meter. So that's why we have 0 minus 5 t t final minus t initial over x final minus x initial over the t final minus the t initial. So we have negative 5 over 3 meter per seconds. So considering that average velocity can be a negative number or positive number no yung result. So it depends kung sa atong na result diri unsa ang position at with the final of specific time. Letter B, find the instantaneous velocity at t is equals to 2. Include units. Wait lang. Okay. We know that the definition of instantaneous velocity is if we graph some curve that is described by the motion of an object or particle. So ang iyang instantaneous velocity ana is a slope pod no? Is a slope with the particular point of time. So just like for example no, instantaneous velocity at t is equals to 2. So this one at this point, di ba? Kaya man ta in every point here sa atong curve is maglahi-lahi man gid ang iyahang kuan ani iyahang slope ani sa atong tangent line. This one diri nga point, so lahi iyang slope sa iyang line. Kanin diri nga point, lahi iyang slope sa iyang line. Diri nga point, lahi iyang slope sa iyang line. So nasay iyahang slope. So nasay makaingon ta nga lahi jud sila og ano, instantaneous velocity with varying time no. Lahi different time no. So at t is equals to 2, so we know that we can get man. So sa shown ani nga figure, so na siya tangent line which is this point is at time is equals to 2 is na siya 3 no. And ni intersect pod siya at time is equals to 1, that is yung distance position is 5 meters. So we can use this no, this point no, these 2 points. So go back into your analytical geometry no, to di ba naman tayo kuan so ang pagkuha sa ihang slope sa line between 2 points, di ba? So we can use this no para makuha nato instantaneous velocity. Here is 2 and 3. Here is 1 and 5. So using our slope formula between 2 points, we have m is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Di ba mo na yung slope no? Sa typical formula. But here is in terms of distance over time man. So or position over time. So ato ang i-formulate diri para makuha nato ang instantaneous velocity. We have position 2, final position minus initial position over the final time minus the initial nga time. So our final nga position is equal to 3 man minus the initial nga position is 5 over the final nga time which is 2 minus the initial nga time is equals to 1. That is equal to negative 2 meter per second. Seconds ato ang instantaneous velocity. So let's have with C. find the equation of the tangent line that is shown in this figure below. So, we already know the slope naman sa kaninga line, no? Which is ang slope is equal to the instantaneous velocity with a time is equal to 2. So, using our definition of the slope, we have y minus y1 over x minus x1. So, it's either inyuhang point nga gamiton diri ba or ari ba nga point. So, it depend, no? Yes. Basta na intersect lang siya ning ko ano, ang inyong point na intersect lang sa kaning line. So, it depend kung ari nga point or kaning point yung gamiton sa kaning paggamit sa formula. So, negative 2 is equals to y minus 5 over x minus 1. Then, cross multiply and rearranging the equation in terms of y. So, we have the equation of the tangent line. So, y is equals to negative 2x plus 7. Okay, so that's all for now. And thank you for your listening.